Yesterday, we have completed going through the Spring Boot 2.x content, and I have made it compared with the application development, what we gonna do using this Spring Boot 2.x content. Similarly, meaning yesterday I told by the completion of Spring Boot 2.x contents, we will be able to complete this web application using the Spring Boot Web MVC and Time Leaf. And of course, if we can see, yesterday we have seen at various levels of or at various layers of the application, the different concepts of the Spring Boot we will learn. Like in services layer, we will discuss about the transaction management. In web layer, we'll discuss about the Spring Web MVC and then Spring REST services. And in this entities repository, we will learn about the Spring Data JPA. Right. Likewise, again, few more additional concepts also we'll discuss. So likewise, each and every layer wise, we'll apply the Spring Boot 2.x concepts, and finally we will build this application. Right. So once we build this application, we will see few problems in this application. And as a solution to that application, we will migrate it to the microservices architecture. So when we migrated it to the microservices architecture, rather having everything inside a single application, the modules were exposed now as a separate independent applications. So these are the modules which were exposed as a separate independent applications. So called microservices, meaning how do we convert the Spring Boot monolith application to the microservices? So this is where just I will showcase the course content for a while, and then we will jump to the our sessions, our regular class. So domain driven design with the bounded context is the first concept we will discuss. Why this is required, sir? Basically, if you can carefully observe, this application have the architecture like this, meaning there is a category module, there is a product module, there is a orders module. These are all the modules will be built as a var file and then deploy that var file here in a Tomcat. So we said with this approach, we will have few problems. And to sort it out that problems, the architecture should be this, meaning each and every module should have to be exposed out, and then each and every module should have its own management, like a database management, JRE, application classes, interfaces. So like if you can see here, entire application is running on a common JRE, right? And common database here we are using common database, common JRE. This architecture have little issues. So due to those issues, right, and to solve those issues, we will move towards to the microservices architecture, right? So we will move towards the microservices architecture. Now, after moving the microservices architecture, see this category module came as one microservice, product module came as one microservice, order module came as one microservice, where the category have its own JRE, have its own interface, its own classes, and its own database. Product have its own JRE, classes, interfaces, and then its database. Usually, if you can observe, every application have some boundary. Every microservices after migrating, every microservices have some boundary. Earlier, these boundaries are controlled by a process. See this? Tomcat process, meaning all these applications or modules like categories, products, orders, all these were again stressed under a process. But here, every application have its own process ID, which have a process boundary. Every application have a process boundary. So how to migrate, meaning how we have to take these applications as a separate applications, right? Getting my point, right? So how do we take these applications as a separate applications? For example, like this. Maybe what I will do is, let me open the diagram, one more diagram, just I can showcase there. So however, how we are taking out the, just let me take it as some test. Just let me keep it as some test, and let me delete this thing. Yes. Now, what we are doing, we are just, meaning we are taking out these applications, right, as a separate applications, like this. So categories management, and similarly we have the products management, right? So we are bringing them like a separate. Now each and every module have their own JRE series, their own process boundary, their own JRE, and also they have their own databases, right? They have their own databases. Now, if you can understand clearly how we have migrated or how we have converted this single process boundary applications to an independent process boundary applications class, how we have migrated a single process boundary applications to a individual application process boundary called microservices, using the bounded context and then domain driven design. So what you understand from this, domain driven design with bounded context is the important, and have the knowledge. Without this domain driven design with the bounded context knowledge, you cannot create the microservices, or you cannot migrate the microservices. Actually, in real time, there are two cases. Microservices, anyone can create microservices from scratch. So in real time, microservices architecture, microservices architecture we can implement in real time. Microservices architecture we can implement. Folks, I think you might, most of you folks might attending this as a demo one or session one for you for this microservices prerequisites I'm writing. So the prerequisite is the Java 8 and advanced Java. If you have, well and good. If you don't have, no problem. And Spring Core. If you have the Spring Core, advanced Java already, you know, well and good. Otherwise, no problem. You will learn this Spring Core here in these sessions. Every day while going on, you will learn it. But advanced Java is, I am assuming that Jdbc, all these things you need to know, preferably Java 8 and then advanced Java. These are only the prerequisite. And optionally, if you have already, if you learn the Spring framework, really awesome. But if you have not learned the Spring framework, you just have learned till Java 8 and advanced Java, that's okay. You can attend these sessions, because we will start from what is Spring framework. That means we'll start from what is Spring framework. Slowly, all the modules or majority of the modules of the Spring framework you can learn as part of this session. Okay, this is the prerequisite. And folks, many of you might have joined today as the first session, right? So you are curious to know the duration as well. So duration is 90 days, or you can say it as the 3 months. Okay, so these are the things. Right, now microservices architecture is what we are discussing. So meaning this application is now converting into this kind of an applications. If you can see now, earlier we have a single database throughout entire all the modules, but here if you can see, each and every module is came out as a separate application and have their own database. Each and every module is came out as a separate application and have their own database. So how this is possible? This is possible using the domain-driven design with the bounded context. The very toughest problem in writing the microservices is, knowing the boundary of the microservices is toughest job. Knowing the boundary of the microservices meanings are those things I will explain once we started, but boundary of the microservices, defining the boundary of a microservices is really difficult. Okay, in real time, when we will get a chance to work on the microservices architecture, then that microservices architectures can be the input for the microservices architectures can be either greenfield, we can say them as either greenfield applications or either brownfield applications. Either brownfield applications, either greenfield applications or brownfield applications. Brownfield applications meaning applications were already there. Applications were already developed and running fine in the production, meaning the customers, end users are using the application, right? For example, your Facebook, your Gmail, or your Twitter, whatever it is, the applications like that, the applications were already running fine in the production, but having little performance issues, having little maintenance issues, assume. So having little performance issues and having little maintenance issues. So maintenance issues. So because of these two issues, the application would like to now migrate to the microservices architecture. So because of these two issues, to solve these two issues, now the application is trying to migrate into the microservices architecture. So this is called as a brownfield applications, meaning applications were already there, and due to the issues in that application, and based on the issues in that application, as a solution, if we will migrate those applications to the microservices architecture, we call them as a brownfield applications. And greenfield applications meaning there is no application, right? From scratch we need to write. So this is called a greenfield applications. So in reality now, in real time now, 80%, around 70% of the applications are, microservices requirements are on brownfield only, right? Around the 70% of the application requirements are on brownfield only. Meaning you guys have to work on mostly migrating a huge application, such a huge application, right? May have the hundreds of the modules, may have the millions, billions of the data in the database. Such kind of an application you would like to migrate to a microservices architecture. So in real time, most of the cases we will get the chance to work on the brownfield applications only. That means applications were already there, you need to convert those applications to the microservices, right? So yeah, terminology might be a little different for you folks at this moment, but 100% going forward you will understand. Just bear with me for a while just to see the content of it. So greenfield applications meaning there is no application at all for a client, and he will develop, meaning we need to develop the application from the scratch. So either it is the brownfield application, either it is the greenfield application, we will apply the concept called domain-driven design with the bounded context. So what do you understand from this one? From this statement, first, domain-driven design with the bounded context, what you understood? What you understood is, in order to implement the microservices, we need to apply a concept called domain-driven design with the bounded context. That is the, you need to understand. How it is, what it is, and all we will discuss going forward. Next, we will discuss about monolithic application. What is monolithic application? Monolithic application in the sense, the application just like what we have seen, right? All the modules are bundled inside a single var file or jar file. That single var file, jar file will deployed into a Tomcat, right? And then have a single database connection point for entire modules of the application. So such a kind of an application is called as the monolithic application. So we will discuss in depth of it actually, what is monolithic application and what are the disadvantages of the monolithic application and why we need to go for a microservices architecture. And what are the advantages we will get if we migrate the same architecture to the microservices. So here in this stage one, we will implement this application using the time leaf, right? Time leaf using Spring Web MVC, right? So this application is a monolithic application. We will have little challenges there. We'll have few problems there. So as a solution to those problems, we'll migrate that application to the microservices architecture. And then we will see the advantages, right? But to migrate this microservices architecture, we need to apply the various concepts. One of the very important concept is the domain-driven design. And in order to migrate it to the microservices architecture to get the benefits and to mitigate the problems that were there with the monolithic application, we need to know about the microservices, isn't it? What are microservices? How the microservices will behave, and what are the characteristics of the microservices, and what are the principles of the microservices. Here, principles of the microservices are must follow principles, must have principles, meaning we have to follow these principles. There were a total of at least we will see two principles of it. One is the solid principle, second one is the single responsibility per service principle. Sorry, one is the solid principle, second one is the autonomous principle. So these two principles we will see here, but other principles also were there. However, microservices characteristics and microservices principles. Without knowing these things, you never win. You cannot work on the microservices. You will feel difficult in understanding the microservices architecture without knowing these 2 points. So ideally, what you guys have to know: domain-driven with bounded context, microservices characteristics, microservices principles. That's it. These 3 things are nothing but the microservices. Without proper understanding of these 3 things, microservices never be understood to you. So very, very careful while learning these concepts. However, then we will discuss the microservices patterns. Of course, this is a separate concept I'm going to discuss later in time. So once we have discussed about the characteristics and then principles of the microservices, then we will start. Now we know domain-driven design. Now we know characteristics. Now we know principles, how the microservice will behave. What are the microservices principles, right? We know now all the enough concepts. Then we will start migration of monolithic to microservices architecture. You may now have asked me a question, sir, can't we write from the scratch? Can't? Of course, microservices we are writing from the scratch only, but it is not for the fresh business functionality. It is for the already defined, already very well executing business. We are migrating into the microservices architecture. Why we are doing that, sir? Because in industry or in the IT market nowadays, 70% of the applications are already existed. They way back already implemented. They are doing business, good business, but facing little problems in their maintenance. Such kind of applications now taking high priority to migrate to the microservices architecture. So that's the reason we will work mostly on the brownfield applications, meaning the migration of the monolithic to the microservices architecture. So which we'll call it as a brownfield. Yes. Yes, going forward, I will give the in-depth of the application. Don't worry. Let us first focus on the completion of this content. Okay, then I will discuss the in-depth of this application, what we're going to discuss. Okay, because we have already the requirements, business requirements captured. So those business requirements and all we'll discuss and then go through the application in depth. However, now, while migrating the monolithic application to the microservices, we will get few problems, right? One is the database, because the database having a billions of records. So how the database right now for all the modules, entire application is using only single database. Now database may have a billions of records. So we can migrate these categories, modules, products as a separate microservice here, and we can separate microservice here, and later we have to attach a separate database also to it. But how the database can be decomposed, or how the database can be identified for a particular categories, for a particular products, and for the particular order management. Basically decomposition. Yeah, so decomposition, right? Basically decomposition of this database is a very tough job for us. So that is the reason we will get the problems like shared DB. Do we need to have a shared DB to all the microservices, or every microservices will have a one database? So the ideal scenario and the ideal architecture of the microservices is suggesting we should have a one database per one microservice. We should have a one database per one microservice for the better management of the microservices. Sir, can we have a single database for all the microservices? Yes, we can have a single database for all the microservices. But again, that will gives us the problems, database centric problems it will gives us. And to solve the problems, we also have like now decomposed the application into the smaller pieces, right? Similarly, we also have to decompose this application into the smaller pieces, where each piece of the database will represent one microservice. So that is very difficult. That is very challenging, because database will have the complex relational tables, isn't it? Foreign keys, right? Indexes, foreign keys, indexes, maybe for the larger amount of the data, databases might have the views, might have the PSQLs, right? And databases might have the complex foreign key relations. So with all these things, dividing this huge database into a small databases, where each and every small database will be a functioning component of the categories, products, orders, modules, that decomposition of the database is very difficult. Here the interviewer will ask more questions to you. More questions the interviewer will ask you. And that is the reason, while decomposing this database, it is little sensitive work, and also it is a complex work. So while decomposing the database, we will apply the microservice pattern. So that's where there is a concept I have written here called microservice pattern. So here we will apply a microservice patterns and provide the solution to decompose, and finally we will develop the architecture like this. If you can see, each and every microservice have its own database. This is the ideal microservices architecture. Okay, now we will have the problems, right? So shared DB, no, it's not a shared DB, but somehow we will go with the shared DB as well. But later on time, we have to change it to the database per service pattern, database per service pattern. Now, how these microservices, now if you can see this entire application, so entire application, category, products, orders, these were all in the single application. For example, if you can go here, I would like to show something to you. For example, this is the workspace. So you might have worked on the Java, right? In Java, when one object needs a data from another object, how they will be collaborated? Based on their method invocations directly, because they know each other, right? When you run a Java main method execution, it will create a process. So within that process, these objects can know each other, and that is the reason method invocations are possible. But here, if you can see, this microservice is somewhere, this microservice is somewhere, this microservice is somewhere. Now assume, in order to order the products, we want the products, meaning order service require the product services. Whereas the product services can be of variety of the categories, meaning product services requires the category services. Now the question is, how these microservices will communicate each other if they are a different applications. If the modules are then inside a single process boundary like this, what I would like to tell you is, for example, you are seeing this application, right? This is a monolithic application. In here, if you can see, there is a controllers, department controller, doctor controller, and then dashboard controller. And this doctor requires the department details. Then what we have done in the doctor service IMPL, we have auto void the department, meaning department object will be called. If you can see here in the yes, here if you can see, while saving the doctor, we are getting the department by the department name and then assigning the department to him. And also wherever the doctor details are required, there we are going to the department object and then get the department details. That is pretty possible. And see here, while also saving the data into the database, we are again calling the address repository and then saving the data into the address. Department repository, saving the data into the department. That means what? As these applications now, whatever I have shown you right in here, whatever I have shown you right here. So these are within the single process boundary. See, entire one application var file having all these applications as a modules. For example, department module, doctor module, dashboard module, right? All these modules we have here, right? That's the reason, as everything within a single process boundary, we will be able to directly access them using their object invocation mechanisms. But if the microservices are different, for example, if you can see here again, so there is a order microservice, there is a payment microservice. For example, see here, there is a payment microservice, there is a order microservice, there is a shipment microservice. Now, shipment microservice is a separate application, order microservice is a separate application, and then payment service is a separate application. Now, how the order service, right? Shipment service requires the order details to ship. We order one product, what is the order ID? What are the products there in the order? What we need to ship to the customer? Those details required to the shipment service. Similarly, payment done or not also required to the shipment service. And payment service required whether the order has been placed successfully or not is required to the payment service. Order has been placed successfully, meaning, let us say I'm trying to purchasing a laptop, MacBook, right? But in the availability, MacBooks are presently available or not, right? That means our order, if the order will be confirmed, then the payment service assume like, oh yes, order is confirmed, then I need to prepare the invoice, right? So this communication, now these are three different applications. You are understanding my point, right? If it is a single application, the communication among the various modules is not the problem. But when the modules are exposed as a separate applications called microservices, then the communication among them is the matter. So that is the reason interviewers will ask us very, very important interview questions called how the microservices will communicate each other, whether they will be communicate each other using the synchronous communication, asynchronous communication. Folks, maybe you don't know anything, the terminology what I am talking about, but don't worry, understand the concept, meaning understand the importance of it. Later in time, technically we will implement it. And at that moment, I will explain what is synchronous, what is asynchronous, the difference between these two. Like that, everything I will explain. You can't believe I will start this session from the what is the framework by writing what is framework, understanding what is framework, what is Java Enterprise Edition applications, what is Java Enterprise Editions, and what is the standard editions, what is the mobile edition, and what we can do with the Enterprise Edition, why we are going for the frameworks, and why Spring came into the picture. So like this, we will understand from the very scratch, very beginning to a master level. But here, you just understand the, thank you. So, but here, you just can understand the course content and then the market expectation, whether we are reaching to the market expectation level to learn the course content or not. That is the importance of it, right? So communication styles, synchronous and then asynchronous, meaning here this microservice is calling this microservice is calling this microservice. Assume how they will be called. So assume order microservice requires to know about the product details. Now order microservice might have called the product microservice, right? Assume product microservice will given the response back to order microservice. Till the response from the product microservice received by the order microservice, if the order microservice will be wait for the response of the product microservice, that is called as a synchronous one. There is an asynchronous way. Asynchronous way is what actually? Payment and then order microservice. For example, order is placed successfully, it will trigger a notification to payment, and this will start taking more orders. If one order is placed successfully, then it will inform the notification to the payment service so that we will receive the payment page. Did you observe when you add the product to a cart, once you click on the checkout, what will happen? Payment page will happen. That means what? Order service is done its job, delegating the responsibility to payment service. Now order will take one more order or many more orders in the meantime, meaning it is a event driven system, asynchronous communication style. It is not waiting till the payment service will give the response back. So payment service will go and then perform the payment, and then later in time payment updates, it will give the response back to this order service in the background, right? Then when in the background, when the payment is done, then the order will be updated its status, like payment completed. Initially order will contain the status payment initiated, then updated the status payment completed, and updated the status shipment started. Like that, the various status of an order can be existed in the database, and such communication is called as an asynchronous communication or event driven communication. So if you can see in our course content or in the banner, you can see, let me go back to the banner. This is the banner I would like to talk to. So in this banner, you can see I have given the one thing called CQRS and Saga. So CQRS and Saga. CQRS and Saga are the event-driven communication of the microservices, event-driven communication implementation in the microservices, right? However, let us go and then discuss the rest of the concept. Now, single JVM or shared JVM. Yes, you are trying to migrating the huge application like this into a pieces like this. Now, here all the modules have a single JVM. If you can see here, my code, see this Medilab preclinic var have a single JVM. See this single JRE. Single JRE for what? Single JRE for department, single JRE for doctor, single JRE for dashboard, right? Single JRE for patient. If any other modules will be added here, for all those modules, the JRE is only one, right? But when we migrate it to a microservice, for example, assume order microservice, it's have its own JRE, and then payment microservice, it's have its own JRE, and then it's have its own JRE, meaning it's a copy of the JRE library, it's reference of the JRE, and then shipment service required a one more reference of the JRE, right? That means what? So every microservice requires a single JVM or shared JVM. So these are the problems that we need to address while migrating the application into a microservices, right? However, the solution for these problems we will address using the various microservices patterns. Then we will go and then see the features of microservices. Yes, we can upgrade the JRE in each microservice. Let us assume this microservice can run on the JRE 1.8, right? Maybe this microservice can run on the JRE 11, and maybe this microservice can run on the JRE 13. That is possible. Each and every microservice may have their own JRE. That is the benefit. That is the benefit. And that's how we called microservices architecture as a polyglot architecture, right? Meaning every microservice is having its own infrastructure, like database, JRE, classes, interfaces, network, server, web server. Everything will be have on its own. That is called that is how we are calling it as a autonomous. Microservices are autonomous. Like universities are autonomous. What they will do in the autonomous universities? Examinations, right? Examinations conducting, and then results evaluation, results meaning the exam papers evaluation, scrutinying of exam papers and publishing the results, promoting the students to the next higher levels. So meaning higher classes. Is everything will be managed by that college itself only, if it have an autonomous status. If it don't have an autonomous status, then it will be like this. It will be work under one university, where that university will have a control on all the colleges. But if it is an autonomous colleges have their own infrastructure. That is how the same concept, like here we can see in the microservices. So that is how the principle 2 of the microservices is saying microservices should be autonomous. Microservices should be autonomous. Okay, however, now let's go and see the rest of the topic. So we will see the features of microservices. And here I have not added one thing. What is that? Microservices architecture we will understand, right? This microservices architecture we will understand with the honeycomb analogy. With the honeycomb analogy. So there were many analogies available to understand, but the best analogy to understand is what, honeycomb analogy. Most of us know honeycomb, right? Honeycomb, the honey bees will construct the honeycomb, right? So that is the best example for understanding the microservices architecture. The honeycomb analogy is the best example for understanding the microservices architecture. However, while discussing the concepts, we will understand the honeycomb analogy. It's a motivation for us to think through the microservices architecture benefits. Microservices analogy is a motivation for us to, inspiration for us to go for the microservices architecture. So there is a lot of fun concepts were there, a lot of motivational concepts were there, inspirational concepts were there in the honeycomb analogy, using which we can confidently implement the microservices architecture as well. Okay, here, like how the honeycombs will construct like how the honey bees will construct the honeycomb, the developers also need to construct the microservices architecture. Every developer is considered as a one honey bee. How it will be, the analogy, how it will be, we'll discuss going forward. Don't worry. However, now we'll discuss here the features of microservices. The features of microservices we'll discuss as we already have done the honeycomb analogy here. So based on the honeycomb analogy, right, we'll be inspired by it, and then we'll get these features of the microservices. Next, microservices implementation using Spring Boot 2.x. So far, what we done? So far, we have discussed about the microservices concepts only. To understand what are microservices, to understand microservice architecture, pitfalls, benefits, right? Communication style issues, lot of problems we were analyzed, we understood, and then finally we have started going to its implementation. So we will implement it. So meaning now finally, whatever the modules we have available, right? Like this. So whatever the modules we have available like this in a single application. This is a single application and having all the modules inside in it, as I have shown now, just now, Docker controller, dashboard controller, like that, right? So like how it is having all these modules are now extracted as a separate application like this, separate applications. Maybe the example I'm showing is irrelevant here. I'm showing the doctor management, hospital management, but here I'm showing orders, payment, shipment. So maybe little irrelevant, but the concept is what, the modules of an application were migrated to a independently executable applications. That's what the microservices definition. There is no proper definition for the microservices, but at least we will understand the microservices with a definition called microservices are autonomous. Microservices are autonomous, self-executed, and independently deployable. So maybe see this, the definition I'm telling you, just imagine department controller, doctor controller, dashboard controller, right? These controllers or these modules, every controller will have again its model. Every controller will have its repository. Every controller will have its service. Every controller will have its service. Every controller will have a bean. That means what? That means what? So the entire huge application, every controller, service, entity, repository, bean, model, all these things we can be take out from here and then termed as a microservice by applying the various microservices concepts. Got it, right? Got my point, right? So in that process, right, while taking out the entire bean, controller, model, repository, service, all these things we will take out from here and then create a project, and again the same structure we will create here, like bean, service, repository, same structure we'll create here, and then map the classes from there to here, and then we will make it as a autonomous, self-executable, and independently deployable. That's it. Then we call it as a microservice. So when something is said to be a microservice, folks, right, when it have a, first of all, when it have a autonomous capability, that means it should have its own JRE, it should have its own network wire, it should have its own database, it should have its own classes, infrastructure, everything. When it is an autonomous, then we can call it as a microservice. Obviously, when it is an autonomous, it will be self-deployable, independently executable, and all. However, so maybe my terminology 100% new for you, or maybe tough for you, but you see the reality of it, and then just assume the understand the course concept. Okay, now microservices were implemented, meaning whatever the application that we have like this, we migrated and then implemented like this, right? Now, the important point here is, where is the security? How to handle the security? How to handle the security of these microservices? So that's where we will use the concept called OAuth 2. OAuth 2 we will use the roles in OAuth 2, OAuth 2 flow, OAuth 2 framework we will use, and OAuth 2 plus JWT we will apply on each and every microservices to secure them, right? For example, category service will be applied with a Spring security, meaning we will use OAuth 2 framework plus JWT concepts, and we will use the Spring security framework, and then we will secure this microservice. Similarly, each and every microservice will be secured using the OAuth 2 plus JWT and OpenID. That's where you can see in my course content, I have mentioned here OAuth 2, OpenID, and then JWT. So these three concepts will apply and then secure the microservices. Okay. Now, once after the security is done, then we will see few problems, microservices data management patterns. right? For that, we'll use Oxen framework, and then, data management, event sourcing, CQRS, right? These are all the additional concepts that we will apply on the microservices to address few of the problems. So that's where you can see here CQRS, Saga, and all, right? So once these are all done, then we will start writing a Dockerization of it. So how to Dockerize it? So while Dockerizing it, each and every microservice, we will write a Docker file. So what I see, this is the Docker file. So later we will write a Docker compose file. So how the Docker file looks like to be? The Docker file looks like to be like this. So what are these statements meaning, sir? How to understand this? Can we able to get it or not? You just relax. Everything you will understand very easily, and everything. It is very easy to understand and very easy to implement. We are not building a rocket, and we are not learning a rocket science, right? Already this is very, very, very renowned frameworks, very, very already a number of options available for us to learn these things, right? Then why again we need to feel it as a difficulty to learn these things? Very easy. But only thing is what, relax, and then attend the sessions, follow the sessions, ask your questions, practice as much as possible, and understand the concept. While I'm telling anything, if you're not able to understand, please, while I'm telling anything, if you're not able to understand, stop me and then ask your questions, rectify it, and then go ahead. Right, now we will write initially the Docker file, and also to manage the Docker, we require the Docker compose file. So like this, the Docker compose file we will write. See how extensively we have written this, right? How extensively we have written this environment. Did you observe? Yesterday I have shown application.yaml file is having with the externalization of the properties, right? It is able to allow the configurations to this microservice from an external file. So that external file is the Docker compose. See this middle app monolithic appdb username, which you can see here. Middle app appdb username, middle app appdb username. Somewhere you can see middle app appdb. Here it is, and see this in this middle app appdb type. So that appdb type you might have used here, right? Meaning externalizing the configurations concept we will implement using the YAML files. Of course, these concepts you will learn in the Spring Boot, right? And then we will extensively use the Spring Boot to implement the microservices and leverage that microservices architecture further to make it as a production grade. Okay, right. So is the Docker file resides in the jar file? No, don't confuse. Docker file not resides in the jar file, whereas jar file will be used by the Docker, or var file will be used by the Docker. So var file or jar file will be inside the Docker image, but not Docker is inside the jar or var. Okay, don't confuse, folks. This is for a terminology I just have shown you, but don't dig into the concepts just now. Okay, because there is a lot to understand before starting about the Docker itself, right? So that is the reason. For now, just listen the concept. And did anyone see this Jenkins file? What is the Jenkins file, sir? This is for not for you. This is for the DevOps folks. Pipeline is a code concept we implemented. So whatever the code you will write, right? Later DevOps guys will use it and then make it deploy. So this file is for the DevOps guys, not for you. Okay, so this is about the microservices course content. I believe you might now got the clear picture of the course content. Dockerization, right? See, if you want to see the Docker content, also you can see the Docker content. But I am not willing to discuss the Docker content right away, because it's not the right time to discuss. Of course, why we discuss the microservices? Because you came here to learn microservices, so you need to know the at least what to be learned and what extent level you need to learn. Okay, now once after we did you observe one thing again? So this is the microservices step 2. So step 1, we will use Spring Boot and then learn Spring Boot concepts and everything. We implement this application called monolithic application. And step 2, we will observe the problems in it and then develop it as a microservices architecture. And step 3, these microservices architecture have the problems, meaning maintenance wise. So that is the reason we will use the microservices cloud agnostic principles to build it as a cloud. This is our final production architecture. Our production architecture is this one. So where we will use, see, we have implemented here these microservices, categories, product, and then order management. Now these category, product, order, payments, all these were now surrounding with many more concepts around it, which is called as an ecosystem. So finally, we need to build the cloud agnostic, cloud native ecosystem using the Spring Cloud, and also the other third-party tools and then technologies as well. For example, Apache Kafka we will use here, and then we'll use Resilience 4J from Resilience 1, right? And then ELK from some third party, WSO2 from some third party, and Eureka from Spring Cloud, config servers from Spring Cloud, API gateway from Spring Cloud, right? So we will apply these concepts, right? Spring Cloud concepts. And if you would like to know the Spring Cloud concepts, what we will cover and all, I believe it's not the right time to discuss, but if you're still interested to discuss, I can go ahead and then see. We will go ahead like this with the microservices patterns we will implement it. Service discovery, services communication, observability, resilience 4J, right? Service discovery, config server, API gateway, Eureka, Joule we are not using, rather Joule we will use the Spring Cloud Gateway. That's what you can see. Spring Cloud Gateway, service registry, load balancer, circuit breaker, rate limiter, logging, tracing, logging. These are all again concepts we will apply using the Spring Cloud. Of course, the logging ELK is not related to the Spring Cloud. And again, tracing will be related to the Spring Cloud. Here in this diagram or here in this banner, you have not seen the histories. Some folks are having the histories in their banner. I'm really surprising, histories is going to be shut down future. Histories is in now maintenance mode. So as an alternate to the histories, we will use the Resilience 4J. So somewhere you might have seen Resilience 4J. Didn't I mention here? Yeah, so these are the Resilience 4J, resilience patterns, right? So circuit breaker and then rate limiter. These are the resilience. So you may ask the question, sir, histories dashboard and histories we have not seen. Don't worry about the histories. Histories is going to be shut down and now it is in the maintenance mode. So we don't need to worry about the histories. As an alternative to the histories, will be providing by the resilience patterns. That's where you can see in our architecture, Resilience 4J we are using to get the same histories benefit, same circuit breaker, rate limiter, right? All the bulkhead pattern, all the concepts like. Okay, finally, if you can see here, the microservices, how we will build, one microservice will use MongoDB, one other microservice might use the MySQL, another microservice might use the Postgre. We will build the microservices with a polyglot architecture. Okay, so that's all for today, folks. And any questions you have, you can ask me. Yes, so high level idea on Docker, not high level idea, folks. I will definitely will give you a very, very low level things, what the Docker and all going forward. However, any questions for me to ask? So tomorrow onwards.
You were saying that you teach how to migrate from a monolithic application to a microservices application. But after attending this session, can we build an application of microservices from the scratch?
Yes. Easily you will build it. Easily you will build. That's what I will take the example of the retail management. Here I will take the example of retail management. You will take the example of the hospital administration management. So like how I am developing here, you also develop parallelly with me with some other use case so that you will familiarize with it. Okay.
Okay,
right.
sir. Thank you.
Sir,
Uh,
Jenkins file and all this Docker file will be explained in detail because I have no idea of Jenkins file and how it works.
this is not required for you folks, not required for the Spring Boot microservices guys. This is for the DevOps folks. DevOps folks will have to work on the deployment, right? So those guys will write the Jenkins file. This is not for us. We don't need to worry about it. And yes, as you said, Docker is required. That's the reason in our course content, a detailed course content has been given for the Docker, if you can see here, right? A detailed course content for the Docker is given. So what to learn Docker, where to start, what is Docker, a detailed course content, right? What is container, what is virtual machine, what is private cloud, public cloud, bare metal problem, right? A detailed explanation of the Docker we will do, and you will go to a master level in the Docker for sure. No doubt in that. So you will write the Docker file, Dockerization for any application, any microservice. Okay, so that's all from my side, folks. So as
Sir, I have a question.
yes, go ahead, please.
Sir, in load balancing, will you teach us like how to manage the load balancer and all?
Correct, exactly. See this end architecture, if you can see in end architecture, we have a application load balancer, network load balancer. How the load balancing will work and all we'll discuss. If you can see everywhere, I used a public network, VPC and all. AWS concepts I used. So I will explain the AWS concepts and then we will use this application load balancers and then I'll cover in depth of it.
Okay.
Hi sir, because this side. Sir, I want to know after taking the class how much experience I can show. I have experience in core, advanced, Spring and Hibernate, but I don't have experience in microservice.
Correct. So after attending this entire session, and if you completed till this one production grade architecture, right, you can put 5 years, 6 years experience also. If you will be able to manage with your documents and all, you can put like 5 years, 6 years also. You can put. It's not a simple digit. I'm saying it is the concept or the work we will do till that level. Yeah.
Okay. Great.
Yeah.
Thank you.
So for a developer, how important it is in recent time to have knowledge of DevOps also, because in trending companies, a developer has to do the deployment also. Rather, they don't have a separate team for DevOps. So can we collaborate this? Like I'm interested in SBMS and DevOps. So can I do the course parallelly?
Yes. If you have the DevOps as a knowledge along with this microservices architecture, you will be like a hot cake in the market for sure, right? And more opportunities you will get, more CTCs you will get if you have a DevOps along with this microservices architecture. I preferably, it's up to you, but I preferably have the DevOps knowledge also for the folks who have this microservices experience.
Okay, sir. And so one more thing, in considering the application, will you be teaching concepts of encryption, decryption of the APIs which are coming in and which are used in real time?
Correct. So those are the part of the security. In security, we'll see this everywhere. We are using the JWT token, right? So how the token will be identified here, how the roles will be retrieved from the token, right? And how the user session will be identified. So all these concepts we will discuss.
Okay. Thank you, sir.
Sir, Ravi this
Hello.
side.
Yeah.
Sir, I have paid the fee and I have still not got access to that Google Drive and these videos recorded.
Yes. Just give me 2 days of time, because within the 2 days of time, probably we gonna change the link. Once the link will be changed, all the assets I will be hand over to you guys. Because once the link will be changed, then we can conclude, right? Only the paid candidates or the interested candidates came onto our class. So for them only, I will provide the assets.
So
Just
all
to
the
give
communication will
So
be
that would
on
be
that
Monday,
email ID, right, sir?
Yes. All the communication will be based on the email ID. And
DURGASOFT online.
Yes, correct. I mean, there will be a this one Telegram group also will be created soon. But Monday I will get a complete report, like how many members have been registered and their email IDs, their phone numbers, and all the information I will get on Monday. So Monday, second half, I will provision you with the assets like documents, source code repository, all the assets I will provision for you guys who have registered.
Thank you.
I want to know actually, are you going to explain the different architectures in microservices, how they are communicating with different clouds also? Like if one microservice is in another cloud and one microservice in Azure or what is AWS. So you are going to explain these all with including the security and whatever the modules are provided in the Spring Boot here?
Correct. That's the concept. Yes.
Okay.
Yes.
Sir, after completing the course, how much amount I can get from a company of 3 years experience?
We will do one thing. Tomorrow again I will show two surveys I will show, but as per the survey and then various companies have been done, the minimum CTC is the 6 lakhs for an entry level engineer, and for a 3+ years guys having this microservices experience, you can demand like 12 lakhs or maximum of 12 to 14 lakhs we can demand. 12 lakhs we can demand for sure as a minimum. Got it? Huh?
Yeah.
Yeah, sir. And one thing, the Spring Batch also we are covering, right?
Yes, folks. I think it's not. Maybe it's my fault. I have not given the course content yet. That's how the questions are coming. Maybe see this Spring Batch is also there for us. Yeah, the detailed course content for sure will be uploaded today. There you can definitely see this one. So Spring Batch also we will cover. Spring Batch, Apache Kafka, Redis Cache, MongoDB. For everything we will have a use case, and how they will be, I already have drafted an architecture where the Kafka, where the cache, right? So where the batching is required and all. I already have drafted an architecture. So slowly we'll implement one after the other concepts.
So from when regular sessions will be started?
Yes. As we were now completed the course content discussion by today, and tomorrow onwards, let us start our regular course content. Let us start with our Spring Core, understanding the Spring Core. I believe whoever already know the Spring Core, Spring Framework, definitely you will get a more add-on knowledge on it. And whoever don't know Spring Core, they will get the Spring Core knowledge for sure. So from the very scratch level, let us start our concepts tomorrow onwards.
Therefore, how many days we will have a class in a week?
In a week from Monday to Saturday. Sunday no classes. Based on need, if you are not able to complete it in the 90 days of the period, then we'll plan for the weekend sessions. But mostly it is from Monday to Saturday. Saturday, let us have a little longer time, like 2 hours, 3 hours. Every day we'll have 1.5 hours, right? Maybe Saturday we can take one more 1.5 hours as an extra, and then we can mitigate. But no classes on Sunday. I'm not going to plan any classes on Sunday because we are all working people, right? So at least have to get some leisure on Sunday. Yeah. Okay, folks. I have to join to another session. So I have to take another session. Those people are waiting there. I'm dropping now. Thank you so much for your interest. And please do complete your payments registration so that I will provision the assets to you as soon as possible. Thank you so much.
Please, sir. Thank you.
Thank you.